This is Outrageous History. Welcome to Outrageous History. I'm Ernest Granson. Science flourished in the late 1800s and the early 1900s, resulting in many momentous discoveries and catapulting names such as Pasteur, Curie, Edison, Einstein, Planck, Banting, and Best into the public realm. One other name which belongs on that list, but which is usually missing, is that of Alfred Wegener. Although not widely known, he's been given credit in the science community for building the case for continental drift, or as he actually called it, displacement theory. That's the concept of a supercontinent known as Pangaea, which split apart to eventually become the continents as we now know them. There's so much more to Alfred Wegener than just this scientific theory, though. And here to tell us about this exceptional scientist and explorer is Mott Greene, Professor Emeritus of Science, Technology, and Society for the University of Puget Sound in Tacoma, Washington. Professor Greene is the author of Alfred Wegener, Science, Exploration, and the Theory of Continental Drift. Thank you for being with us today, Mott.
Well, thank you, Ernest, for having me on your program.
Well, Mott, maybe we could begin by creating some perspective of Alfred Wegener's achievements, because those achievements were by no means limited to his endeavor to gather evidence for his displacement theory. And actually that scientific area, geology, wasn't even his specialty, or not to start off with. He finished his education at the University of Berlin as a postgraduate in astronomy, but then he went on to specialize in meteorology.
Yeah, it's first of all, one of the interesting things for me about the early 20th century is the lines between fields were not as clearly and sharply drawn as they are now. For instance, you mentioned Pasteur among the great scientists. Pasteur, although he's famous for the way we process milk and the germ theory of disease, was actually a crystallographer. And at the time when Darwin proposed the theory of the origin of species, he was famous as a geologist, right? So there's one of the things about Wegener's career and the careers of many of these interesting scientists is the importance of outsiders to a field. Not that they're not trained, they're not autodidacts, but that it's very interesting the way it's possible to approach a very hard problem with fresh eyes if you haven't been trained in the field where that problem exists. You really can have a fresh look. But with regard to who Wegener was, he at the time that he proposed the theory of continental drift, or displacements as he called it, he was best known as a polar explorer. He had been on a very famous expedition to Greenland in 1906, and shortly after that, he made a world record in time aloft in flying a free balloon. So he was known as an aeronaut and a polar explorer. And right up to the time that continental drift began to be discussed, which was mostly in the 1920s, he was known inside meteorology, which was his field, for an original and turns out a correct theory of how raindrops form, an original and a correct theory of why tornadoes form in thunderstorms, why the atmosphere is layered the way it is, and so on. So if you ask somebody in 1912, who's Alfred Wegener, and they say, oh, he's the author of thermodynamics of the atmosphere. He had that record in the balloon. That would have been, and only went to so this is not that uncommon for people to work around in their scientific youth, especially in the 18th and 19th centuries, or 19th and early 20th, before they settle on a field. And very often, I think, one of the things that happens is that these scientists don't so much settle on a field as create a new field where there wasn't one before. And I think that's a lot of the originality. It's certainly what Planck did with quantum mechanics. It's what Pasteur did in bacteriology. It's what Darwin did with the origin of species. So I think Wegener fits into that group. the outsider, the fresh eyes, had a good scientific reputation, but ended up being famous for something that was very, very far from his training and early interests. So.
Well, so let's move into the reason why he came up or developed that theory in the first place. That was about in 1910 that he seemed to experience a revelation of sorts when he and a colleague were looking at a world atlas. I mean, and he didn't really discover continental displacement on his own. As you put it, continental displacement discovered him.
Yeah, it's true. He didn't mean to do this. He first of all, when we look at a map of the world or a globe of the earth, I don't think there's anybody over the age of 12 who hasn't noticed that the east coast of South America and the west coast of Africa fit together. And you go, huh, right? And then usually that you feel, oh, that's interesting, and then it goes away. What was interesting about the map and the atlas that Wegener looked at in 1910 with his office mate who'd just gotten this new atlas for Christmas, this was the first atlas ever produced that had depth data for the Atlantic Ocean. And when Wegener looked at the map, he talked to his office mate, and he said, look at this. Not only do the outlines of the continents match, but they match down at 200 meters below sea level and at 4,000 meters below sea level. And he said, so this isn't an accident of sea level that these things match. There's something going on in the earth. And then he put that aside, and a year later, when getting ready to go on an expedition to Greenland, was looking for information about the geology of Greenland because he didn't know any geology, but stumbled on an article right next to the one he was looking for that was about how much the plants and animals in the geologic history of Eastern South America match those in Western Africa. And this started him going again, and he realized that there was a case to be made for these continents actually to have been together before. Now, the difficulty here is the manifest improbability of this, right? It's like a Copernican problem. If you've grown up thinking that the Earth is the center of the universe, and then somebody tells you that the Earth moves, you say, well, that's nuts, right? It defies common sense. And you think the continents, we talk about the Rock of Gibraltar being solid. Well, I mean, how solid are the continents? They're gigantic. How can they move around? I mean, they can't spin around like pats of butter in a hot skillet. There has to be something going on. But the interesting thing about this theory, as outlandish as it originally appeared, as it turns out to be true, right? And so the devil, however, is in the details. And I think one of the things that Wegener had in great abundance was patience and the ability to sit down and read to find out if there was real support for this and how it could be supported. And he also had a kind of something that was also rather unusual, a historical view of what it means to propose a new theory. He said, this is a new theory. People are going to think it's crazy. People are going to think it's revolutionary. Could be 10 years, could be 30 years before it gets established. I might not be able to do it, but this is going to happen because not so much because this new theory is so wonderful, but because the old one doesn't work anymore. So,
well, that brings me to this point, because a lot of the material, or some of the material, anyways, that I've read while I was researching for this podcast, there are the suggestions that Wegener was severely criticized for that theory and almost ostracized. Now, as you mentioned, he was fairly young when he came up with it originally, and a relatively new scientist. I got the impression from your book that the peer reviews of his books about this subject and articles and his presentations were actually mixed, and that there was some deserved objective criticism, but there was also positive commentary. For instance, you mentioned Edgar Duck, who greatly praised his 1912 paper. Granted, Doc was a paleontologist, not a geologist.
Yeah, and so here's one of the difficulties about a theory like this is that geology, the history of the Earth, is made up of a bunch of specialties. People who do the chemistry of rocks, people who are paleontologists, people who look at the structure of mountain ranges. Each of these is a separate field within. Now, if you're an outsider like Wegener, gathering together lots of information from these different subfields, you're gonna stumble every once in a while and make a mistake. And so the guy who's the paleontologist asks the structural geologist, "Is his structure any good?" And the structuralist says, "No." And then the structuralist says, "What about his paleontology?" "No, he's made a mistake here too." So I don't know if this. I mean, the focusing on mistakes is a real part of how science is done. On the other hand, there's no doubt that geologists saw him as a young, smart alecky physicist barging into the room and trying to take over their science, and there was considerable resistance to that. And I think one of the things that I would want to say about this is because we're talking about the question of making a discovery and then getting it accepted, right? So one of the things I found out in studying the history of the sciences is that scientists love novelty, okay? Because within the context of an existing problem, you get a little bit of this new, a little bit of this, say, "Oh, look what he did, that's great." They like novelty, but they hate originality, because novelty is familiar, exciting. It seems to advance the field that you're in. It fills out the structure. But real original work is what the hell are you talking about? This is nuts. That's so. People said that about Einstein's theory of relativity. They said about Darwin's Origin of Species. I think this is a problem with in which, historians of science are fond of saying that there's two ways to make a contribution to science. One is to change an answer, but the much bigger one is when you're the person who changes the question. And when you change the question, that's where the originality comes in, and that's where it becomes really kind of scary for the people in the field. Who, after all, if some guy says you're wrong, your entire career is in jeopardy, right? Your reputation is up for grabs.
Well, you mentioned in your epilogue that Wegener's displacement theory, the way he presented it, was never really accepted in that form. So what's the relationship between that theory and the eventual development of plate tectonics?
Well, yeah, that's a good question, and I think the Wegener said about his own theory, this won't be accepted until all the people who believe the old theory are dead, because that's the way it goes. Mm-hmm. But also, we talk about Darwin's theory of evolution. The theory of evolution that we have today has very little to do with what Darwin said, particularly. It has different mechanisms, it works in different ways. And just Wegener's theory of continental drift is very, very different from plate tectonics. It has a different mechanism. But and so if we go through having an original idea, one of the things about Darwin is that, I wouldn't go into that, because Darwin's theory there are Darwinians today, but there are no Wegenerians, right? And I think what happens is it became I think the best way to say this, when plate tectonics became accepted, people dug up Wegener's old work, republished it in a Dover paperback reprint. Geologists looked at it and they said, "This is great. How could we ever have rejected this?" And so then they go back and start looking at it and finding, well, this was wrong and that wrong and this wrong and that wrong. But the fact is, what they end up saying is, well, there are lots of reasons why this didn't get accepted. and most of them extrinsic to the theory itself. I mean, the greatest obstacle to the theory, Ernest, was it was proposed during and after World War I by a German. And the Germans lost the war. And I remember a review written by a very famous geologist at Johns Hopkins. And he said, are we going to win the war against the Germans on the battlefield and lose it on the scientific front, to the Germans? So that was there. And also Wegener had the great misfortune as a theorist to die as a young man, right when he needed to be there to be the advocate for his own theory. I mean, he was born in 1880. He probably wouldn't have lived much beyond 1950. But by then, people were already working on continental displacement again, and so he might have had some contact with them. But there's no doubt that he deserves the credit for continental drift, but he doesn't deserve credit for plate tectonics.
Right.
Yeah.
Well, so he as you say, he deserved credit for that current form of a theory. And you pointed out a number of different areas that he also became expert at. But I would like to go into his polar, well, they weren't polar explorations necessarily, they were Greenland exploration, but
yes.
That was something that he was really driven to do. He went on the original one, set aside his academics, even against the advice of almost everybody he knew. And then he went on to several others.
Yes, this was the great age of polar exploration, 1906, 1907, when he went into the Arctic. Nobody'd been to the North Pole or the South Pole yet. Admiral Peary kept pushing and pushing towards the North Pole. Nobody'd been to the South Pole. And I think for young men, in particular, since women didn't do that exploration in those days, although they do now, it was the dream of a lifetime to make your reputation as someone in the North. Okay, these were the last parts of the Earth where no one had been. When he crossed Greenland in 1912, one of the things that they were looking for is, believe it or not, the Danes who controlled Greenland knew that there had been Norse settlements about around the year 1000 in Greenland. And there was a rumor that in the middle of the Greenland ice cap was an oasis where the Norsemen were still living, right? And that they had been trapped in the ice. And one of the things that this expedition, it was a Danish expedition, advertised itself as going to do was to prove or disprove the existence of this kind of island universe in the middle of the ice cap. Of course, it's not there, but along the way, they did originally. I mean, nobody had ever been across the ice cap, certainly not under those conditions. And this was not. There was no logistical support then, no radios, no airdrops. This was, you went out there with some food and a dog sled and a gun and hoped you make it back, and then but his first two expeditions were very much kind of just exploring adventure travel, although he did do science on both of them. But the big expedition that he undertook in 1930, the one on which he lost his life, was very much a scientific expedition trying to bring radios and seismic equipment and the new things into the study of to support the study of the Arctic. So, but he was so famous as an Arctic explorer that when his body was discovered in the ice, he had perished trying to resupply a mid-ice base. It was front page news in the New York Times for 4 days. The New York Times wrote an editorial about it. The Germans and a German-American company made a film called SOS Iceberg, starring Leni Riefenstahl in 1931, about the attempt to find Wegener's lost diaries in Greenland. And he's portrayed in this film as there's Amundsen, there's Nansen, there's Scott, the greats, and here's the greatest of them all. And these two cigar-smoking men look at this portrait of Wegener and point to him. So that's what he was known as then. Had he not been famous for anything else, that probably would have been enough to secure him a reputation. Not least because he doesn't have a geographical or geological institute named after him in Germany, but the German Center for oceanographic and polar research is the Alfred Wegener Institute. So that's really his legacy there.
Well, speaking of cigars, I first of all, I have to say that the descriptions of all three of those expeditions were kind of mind-boggling to me in the difficulties they had with not just the weather, but the logistics for supplying those expeditions. I couldn't believe that they could even make it through there. And then when you wrote about the final expedition, well, you could kind of see which he and a colleague were actually managing. He sort of set himself up for his demise. The stress that he absorbed, he had heart issues, and here's the cigar. He was a cigar chain smoker. So, what happened in that final expedition, and that's where his body lies now. Is that true?
That he's in the ice, and his wife said, they said, "Do you want us to bring his body back?" And she said, "No. He always dreamed of a Viking funeral. If he's frozen in the ice, eventually he'll float out to sea in an iceberg." So, but yes, the hardships that are almost unbelievable. Now, I mean, everybody got frostbitten, everybody got sick, everybody starved. It's a savage world in which you have these dogs work themselves half to death pulling your sled, and then you shoot them and eat them, or you have these wonderful Icelandic ponies pulling the sleds, and you shoot them and eat them one after another. And it's just, there is a savagery and a desperation about Arctic travel, which isn't there any longer. I mean, I don't know if we're capable. We could manufacture explorations like that today, but they wouldn't be real. I mean, you went up to the Arctic, you disappeared, you were gone for years. Maybe you come back, maybe you don't. So, but certainly, as to the question of his death, I've known a lot of people who are heavy smokers. I've never even read about anybody who smoked as much as Wegener. His wife said about him, I said it somewhere in the book, she'd go into the study and there would be a haze of blue smoke in the study about 4 feet above the desk, like a stratus cloud that would just, constantly there, constantly tobacco. He wrote poems about tobacco.
A huge part of his life, I imagine. Tobacco would have been a big part of the supply chain in his expeditions.
It wasn't that and alcohol. I mean, we know that alcohol isn't such a good idea, but if you read the Danish expedition that went in 1906, my God, half the hold was full of brandy and beer and champagne bottles. On the way over, they planted. So.
Now, he was also, as you mentioned earlier on, a highly regarded aeronaut, along with his brother Kurt, and balloons were a big part of his life.
Yes, they were. They were an important part of meteorological research, which, of course, he did, both with captive balloons that you send up the way we do now, but going up in balloons. And I think, actually, that's an underrated part of his understanding of the Earth, because geologists have a beautiful, it takes a real good three-dimensional imagination to be a geologist, but typically geologists before the beginning of aerial photography did not see the Earth from the air. And he did. He had, in the balloon, you get the long distance view. You're up 5,000-6,000 feet and you can see a long, long way. And the curvature of the Earth is so obvious to you. Of course, he was an astronomer, so he dealt with the Earth as a spherical object and was used to seeing the Earth as a ball in space next to others. But that 1906 balloon flight was, aeronautical contests, first with balloons and then with fixed aircraft, were a kind of a benign Olympics of international competition. Would the German team beat the American team for the time aloft, or these sorts of things. And but his adventures in ballooning were hair-raising. I was looking for an epigraph for one of the chapters, and I found it in about a terrible balloon crash that he had. And the Encyclopedia Britannica for 1911 has in its description of ballooning, one of the chapters is the chief danger in ballooning lies in the descent.
Everything is good until you have to land.
Yes, right. So,
So I think it's safe to say that Alfred Wegener would not be troubled by the fact that his name might not be recognizable by the general public. I mean, he didn't really seek out public recognition. He made it pretty clear that he was totally devoted to science as its own pursuit. And you quoted him saying in 1929, to the scientist, the holy of holies must be the discovery of the world around and its laws to which he dedicates its life. The economic motivation that scientists today assert to get funds for their research are in the majority of cases hypocrisy, something like Kepler paying his way by casting horoscopes. That's pretty harsh, but that's how he lived his life, isn't it?
It is how he lived his life, yes. And one of the things he devoted himself to, Richard Feynman said, the secret to physics is not being fooled. And the problem with doing physics is the easiest person to fool is yourself when you're doing science. And Wegener worked very hard not to fool himself and not to be fooled. And he did feel he had this almost religious devotion to the idea of science, not untypical in Germany at that time. That this was not just some kind of glorious quest, but it was part of human evolution, that we were going to emerge to as better than we were before by understanding the realities of the natural world. And he said, this is worth risking your life for. I'm glad to do it, so that's.
Now your biography consists not only of the lifeline of Wegener, but you have a lot of details about his peers and even those preceding him. Now, you spent literally decades in obtaining all this information. Now, how did you feel once this book was actually completed?
Well, first of all, I said, when younger historians of science say, should I write a biography? I would say, no, don't do it. But it took longer than I thought. And I think this happens to biographers. I met halfway through it, I met the biographer of J. Pierpont Morgan, who was the financier, a good historian named Jean Strauss. And I said, how long have you been working on it? And she said, 12 years. And I said, are you done? And she said, no.
Oh my gosh.
I think it was going to take you. She said about 5. And I said, yeah. You don't find out until too late how long it takes. But I will say now, everything would have happened a lot faster if I'd had access to Wikipedia.
Oh yes. Now, how much of the diaries were you actually able to uncover? Were there any that he left?
Yeah, all his expedition diaries from 1906, from 1912, and 1929 to 1931, except for the very last diary that he was writing in when he died, which has never been recovered.
Oh.
All of those diaries are in Munich, and they had their wonderful reading. He had very good, clear handwriting in pencil in these beautiful little kind of Moleskine style diary books. And but I had quite a shock. I read the 1906 diary, and then I opened the 1907 diary, and it was in Danish instead of in German. And he said, I'm on a Danish expedition. I have to learn the language, so I've decided to keep my diary in Danish. So we had a brief reconfiguration while I went back to school and learned enough Danish to read a diary.
So you had to translate that yourself?
Yeah, I had to translate it myself. Yeah.
Oh.
They have since been translated, and all these diaries are now online, as a lot of film footage of Wegener, and the Alfred Wegener Institute has done some wonderful things getting these materials together. But it's interesting. But this was a book that began and was largely completed before really computer-aided research came to the aid of historians. So just as Wegener's perhaps theory was an artifact of an earlier age. So is my biography of Wegener, an artifact of an
Oh, I remember those days. Yes. Now, you actually made a trip to Greenland yourself at some point during the research here.
I did. I wanted to. I was told by the biographer of Michael Faraday, you should read everything that the guy wrote, read everything that he read, and read everything that the people he read, if you can do it. And he said, but what's equally important to that is to go everywhere he lived and see everywhere he worked. And I took that advice very seriously. And that meant, what would it be like to be on the Greenland ice cap? So with some cooperation between the Greenland authorities and the US State Department, I was able to hitch a ride on a mining company helicopter to go beyond the end of civil aviation. And then their environmental officer took me over in a Zodiac and dumped me on the shore. And I hiked up a glacier and found the camp where his base camp from 1931, and then went up and spent a few days on the inland ice to see what it was like.
So there's actually signs of that camp still there?
Oh yeah. One of the most touching ones was that they had Icelandic ponies to get the stuff up the glacier, pack ponies. And on this rocky field, there was a square, about 50 by 50 feet. And it had this beautiful green grass growing on it. And that's where the horse pen had been. And there's like 1,000 years of topsoil from the horse manure in 1 or 2 years. So, but I kept finding fragments of, crates that said Wegener expedition and pack harness. And if I'd gotten there a year or two sooner, the propeller driven sleds that they used for the first essentially snowmobiles that were used on this expedition were right there in the ice, frozen right at the top. Oh,
really?
They had just been dug out and taken to the museum in Umanak, about 40 miles away by sea. And
so it's hard to believe that they would still be in that kind of shape, because were they not made out of plywood?
Well, the plywood was gone, but what you could see was all the metal and the steering component. All of that was still there. And,
that must have been quite surrealistic for you to see that it was still there.
It is, and I was really glad I did it. I mean, in terms of what I found out about the Wegener, it wasn't much, but the emotional connection, which I think a biographer requires, was very much advantaged by having been where he was there. And boy, the inland ice is pretty scary. I'll tell you that. It's just I wouldn't go back again.
Unlike Wegener.
Yeah.
Well, to wind this up, Mott, in your book, you quoted a science historian by the name of L. Pierce Williams, who said, the biography of a man of science can never end with his death. And I guess that can be said of Alfred Wegener.
Yeah, I think that's right. We find out long after their lives are over what their work has meant. And I think many scientists are carried forward in their work by feeling maybe nobody understands today, but someday maybe somebody will understand. And a lot of highly original scientists facing rejection have had to feel that. And but I think it's what keeps them going. And I do think, I mean, his biography is an ongoing matter. I think that the Germans recognized even later than some of the rest of the people in the world how important he had been, and decided to name their institute the Alfred Wegener Institute. I mean, that was a big deal. That was in 1960. So it's still ongoing. Yeah.
Well, Matt, I thank you so much for leading us through this journey of science and exploration.
Thank you, Ernest. Thanks very much.
And I thank all of you for tuning in today. And just a reminder that we've recently launched our Outrageous History website. So if you'd like more information about the topics discussed in our podcasts and about our authors, log on to www.outrageoushistory.com. Thanks again. I'm Ernest Granson. Outrageous History is produced by Northern Flicker Media.